So in a previous video, you learned about where the periodic table came from. So in this video, we're going to sort of take a tour of the periodic table. So here it is. So the first thing to notice about the periodic table is that it is marked off in columns and rows. So again, Dmitry Mendeleev sort of arranged these elements based on certain properties. So the periodic table has this funny shape that it does, not because Mendeleev thought that was a good shape, but because the elements themselves, their properties, caused the periodic table to have this shape. So first off, the columns of the periodic table, let's see, we'll write this up here, columns, C-O-L-S. Oh boy, I'm not such a good writer. Anyway, columns of the periodic table are called groups. So groups. The columns are called groups, and the rows are called periods. Periods. So what we know about a column is all of the elements in a column will tend to have similar types of chemical reactivities. As we move across a row, the chemical properties will tend to vary in a regular predictive way. So in this way, that's how Mendeleev was able to predict properties of elements that were new to him, like gallium that's down here that I'm kind of waving my pointer over. Okay, so the columns are called groups, the rows are called periods. There's another really important division that you can make in the periodic table. So it turns out that if we draw a big stair-step line right here, so I'm going to draw a big stair-step line right here, so we're making stair steps that go all the way down this little section of the periodic table, like that. Then we've roughly divided the periodic table into two parts. This part over here, these are all nonmetals. And they have properties of nonmetals. And most of them are gases. The ones that do form solids form brittle solids. That means they tend to powder when you smack them with a hammer and turn into dust. So the properties of nonmetals. They're not good conductors of electricity. In fact, they're insulators. They tend to also not to be very good conductors of heat. On the other side of the staircase line, over here on this side, these are metals. So again, the fact that we have nonmetals over here and metals over here, that's just the way that nature wanted this periodic table organized. So Mendeleev figured out that in this order things have repeating properties, and it just so turns out that these are metals over here and these are nonmetals over here. So right along this line, then we have some materials that sort of have properties of each kind of material, metals or nonmetals. And so the elements that are right along this stair-step line are called metalloids. So these elements that are right along the stair-step line, so I'm going to highlight those: boron, silicon, germanium, arsenic, antimony, tellurium. Those guys right there, those are what we call metalloids. Or sometimes they're called semi-metals. And they're going to have properties in between metals and nonmetals. Silicon, in fact, is the material that makes up computer chips. So if you've ever taken out a computer motherboard and looked at one of those chips, you'll see that the surface of a chip is a little bit shiny. So that's kind of a property of metals. Metals, we expect them to be lustrous or shiny. But if you smack a silicon chip with a hammer, it's going to be brittle. It's going to fragment and make a little powder. So that's a property then of nonmetals. And in terms of electrical conductivity, these semi-metals, these metalloids, tend to be semiconductors. So they conduct electricity under some conditions, but not others. They tend to be insulators. So that's a really useful property for computers because they can make electrical switches. We can turn them on so that they let electrical current flow, or turn them off so that electrical current doesn't flow. And we can use that to represent information inside a computer in the form of binary, either on or off. So metals over here, nonmetals over here, metalloids in the middle. So let's talk a little bit more about some specific groups. So some of the groups have special names. So let's name some of them. So this group right here, this first column of the periodic table, these are called the alkali metals. So again, they're metals. Alkali. That's supposed to look like a K there if you can't tell my writing. So alkali metals. So these are the metals. Oh, what about hydrogen over here? Well, hydrogen, it turns out, is a nonmetal. Now it's a very special element because it only has one proton and one electron. Oftentimes you'll see hydrogen written in periodic tables like floating out here in the middle, or maybe they'll put it over here because it sometimes has properties that are like some of these nonmetals over here, fluorine, chlorine, bromine. So sometimes you'll see that hydrogen atom over there, but it is a nonmetal. Hydrogen behaves like a nonmetal. So these then are metals, and they're called alkali metals, and they all have similar properties. So when you throw them into water, they're very reactive. So taken together, these two first columns of elements are called the active metals because they tend to be very reactive. In particular, these are. So it's fun to go onto YouTube and watch videos where people are throwing these things into water because they release a lot of hydrogen gas and enough heat to ignite that hydrogen gas. So you oftentimes get big and impressive explosions when you do that. So those are sort of fun to watch. This next column right here, it's headed with column 2A. Oh, by the way, I forgot to mention this earlier. The official IUPAC name is to go through and number each column with a number, 1, 2, 3 through 18. An older style uses either numbers and a letter or a Roman numeral and a letter, and it turns out that these are very helpful, as we will see. So the A group elements, the ones that have an A beside their number, so these over here, and these over here on the right-hand side, but not the ones in the middle, the A group elements are called main group elements. So main group elements. So if you ever hear chemists talk about main group elements, they're not talking about these guys. They're talking either about the ones on the right or the ones on the left. So back to group 2A. The group 2A metals, again, these are metals, these are called alkaline earth metals. So alkaline earth metals. You tend to find them in alkaline solution. They make solutions basic. Alkaline is another word for basic. So we're talking about a chemical property here, acids or bases. So there we go. These are beryllium, magnesium, calcium, and so forth. These are the alkaline earths. Over here then, going to the other side, group 8A, right there, helium, neon, and so forth. These are called the noble gases. Sometimes they're called inert gases, and they're called inert gases for a good reason. These all exist as monatomic atoms, and they tend to be very, very non-reactive. So they're all often used in applications where you need a gas surrounding something that's not going to cause it to react with anything. So you'll see these in light bulbs and so forth. So these are very unreactive elements. In fact, it's curious, well, why would these elements be so unreactive? In fact, they tend not to form compounds with very many other substances. There are only a few compounds known containing argon, a few more with krypton, and none containing neon that anyone has ever found, to my knowledge. So over here then, our next group, group 7A right here, these are called the halogens. Halogen comes from a Greek word meaning salt former, and these are components of salts that you'll see oftentimes. They're also very reactive gases, so they exist. Fluorine, chlorine are gases at room temperature, F2 and B2. They're all diatomics. We've talked about those. Bromine is a liquid under room temperature and pressures, and iodine, I2, is a solid under room temperature and pressures. They all tend to be fairly reactive. In fact, fluorine is vigorously reactive, very bad stuff, and they all tend to be fairly toxic if you were to inhale the gases. So over here, these other elements then, these are also nonmetals, carbon, nitrogen, oxygen, sulfur, phosphorus, and these are elements that are important then in living systems, as it turns out. So there are a lot of these elements in living organic structures, particularly carbon, oxygen, and hydrogen over here, another nonmetal. Okay, so those are some names of some groups. Let's look down here. These two groups that are floating out here, this little island, well, where do they occur? Well, they actually get sandwiched in right here. You see this little arrow. So element 56, barium, you'd move right down here to element 57. Well, why not just insert it right here? Well, sure, you could do that, but then that makes the periodic table really long. Sometimes you'll see it like that. This is analogous to how when you see a map of the United States, for example, they sometimes put Alaska and Hawaii floating down here off the coast of Mexico, if this were a map. But, you know, they're not really there. So we do that with these two groups. Taken together, these groups are called rare earth elements. Rare earth. They're called rare earth elements because they're not found very often. In fact, many of them are unstable and radioactive, so their nuclei are unstable and they tend to break down to form other elements. So the nucleus essentially falls apart. But anyway, so going from here, lanthanum, all the way to terbium over here. This series is called the lanthanides. Then we have another series called the actinides because it starts with the element actinium and goes all the way over here to the element nobelium right here. So those are the rare earth elements, and those are those two rows. So those are the two rows that have special names. So there's a brief tour of the periodic table. You've already talked about what all these symbols here in an element symbol mean. So there's the atomic number there. The element symbol there, and then there's the average atomic mass in atomic mass units that's there. And again, the elements are ordered as you move across the table from left to right in order of atomic number of protons, right? And then we repeat properties, that's why it's called periodic, every so often. So when you go from sodium to argon and then the next element, potassium, well, potassium tends to have properties that are very similar to sodium, so that's why it gets put in the same column, the same group. Alright, so there's your brief tour of the periodic table.